energy like yesterday. We would like to read several agendas today.
First is speaker session part 3.
Second is break.
Third is speaker session part 4.
And the last one is closing.
Before we start, we would like to remind you to fill the link form that can be accessed through the screen. And please write your full name clearly because it will be used for the certificate.
Okay, maybe the next session, the speaker session part 1, and this day will be started at 8:15 a.m. Western Indonesian time. While we waiting, I would like to tell you the first speaker session part 3 will be delivered by Dr. Ganjar Alfian from Dongguk University and will be moderated by Mr. Ahmad Fatan Hidayatullah. And speaker session part 4 will be delivered by Dr. Chandra Kusuma Dewa and will be moderated by Mr. Domas Hatta Fudoli. We will start at 8:15 a.m. Western Indonesian time. Thank you.
And before we start, please don't forget to register through the registration link that can be accessed on your screen. Thank you. Bismillahirrahmanirrahim.
Assalamualaikum
warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome back to International Webinar Center of Data Science, Universitas Islam Indonesia 2021, Day 2.
We hope we have some energy like yesterday. we would like to read several agendas today.
The first is speaker session part 3.
The second is break.
Third is speaker session part 4.
And the last one is closing.
Before we start, we would like to remind you to fill the link form that can be accessed through the chat box, and please write your full name clearly because it will be used for the certificate.
The next agenda will be going to start at 8:15 a.m. Western Indonesian time. Thank you. Okay, maybe we will start earlier. The next agenda is speaker session part 3 from Dr. Ganjar Alfian from Dongguk University, Korea, entitled Machine Learning and IoT for Food Supply Chain and Healthcare Monitoring System. This first talk will be moderated by Mr. Ahmad Fatan Hidayatullah, ST M.Cs. Firstly, Mr. Ahmad Fatan Hidayatullah is a lecturer at the Department of Informatics, Faculty of Industrial Engineering, Universitas Islam Indonesia. He is currently pursuing his PhD in Computer Science Program, Faculty of Science, University Brunei Darussalam with the UBD Graduate Scholarship. He earned his master degree in Computer Science, M.Cs, from Universitas Gadjah Mada, Indonesia in 2014. Previously, he completed his bachelor degree in Informatics in 2010 from Universitas Islam Negeri Sunan Kalijaga, Yogyakarta, Indonesia. His research interests are mainly related to text mining, natural language processing, and data science. He is also actively involved in several research in Center of Data Science, Universitas Islam Indonesia. To Mr. Fatan, time is yours.
Okay, can you all hear my voice clearly, right?
Yes, sir.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thanks to the Master of Ceremony for introducing me. And then, first of all, I'd like to thank to all participants. Yeah. Thank you for joining us in the second day webinar, International Webinar Center of Data Science, Universitas Islam Indonesia. It is a pleasure to have you all here. And then I hope everyone is doing well and blessed by Allah Subhanahu wa Ta'ala. And hopefully the situation of this pandemic will get better soon so we can meet directly. Yeah. And before we start our first keynote session for the second day, let me introduce our speaker. Yeah. In this occasion, we will have Dr. Ganjar Alfian. Actually, he is my senior when I was undergraduate at UII Sunan Kalijaga. It is a pleasure to have you here. Thank you for joining us, and we are very happy to meet you and collaborate with you. And hopefully, we can, we can have more collaboration in the future with Dr. Ganjar. Okay, let me read the brief biography of Dr. Ganjar. Dr. Ganjar Alfian received his master from his PhD. I'm sorry, from Dongguk University, South Korea, in 2016, and he got his master in 2012. 2012, sorry, 2012 or 2012 from Dongguk University, and he graduated from Universitas Islam Negeri Sunan Kalijaga in 2009. And his research interests, we can read here. There are so many interests, artificial intelligence, machine learning, RFID, IoT, simulation, big data, health informatics, and also car sharing. Okay, without any further ado, because there are so many publications from Dr. Ganjar, it will take a long time if you read all of his publication. So without any further ado, please Welcome, Dr. Ganjar Alfian. The stage is yours. Thank you.
Right. Thank you very much, Pak Fatkan, for giving us the introduction of myself. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Before I start, I think I should share the screen. Is that okay?
Okay.
Yeah. So, first of all, thank you very much for Center of Data Science, Universitas Islam Indonesia, for giving me the opportunity as a speaker for this morning session, international webinar. Secondly, also thank to Pak Fatkan for brief introduction of myself. So for this morning session, the title of my presentation is Machine Learning and IoT for Food Supply Chains and Healthcare Monitoring System. So basically, this is based on our previous project that we have done in South Korea, Dongguk University. This project was result from it is from collaboration between several university as well as IT company. And for these cases, I would like to show you how we can utilize the technique in machine learning and how we can utilize the IoT sensor device for two case study. The first one is food supply chains, and second one is for healthcare monitoring system. If you have any question related with this matter, related with this research, feel free to contact me through this email, ganjaralfian@gmail.com. I will be very happy. Maybe in the future, who knows, we can collaborate for some certain research. So if you have any question, then you can contact me. I will start. This one is a brief introduction about myself. Actually, Pak Fatkan already explained before. The content of my presentation is that I will give you first introduction, just briefly introduction about machine learning and how this technique in machine learning can be utilized for different cases. And after introduction of machine learning and IoT, I will go to first case study. It is food traceability system. How we can utilize those technique for food traceability system. And the second cases is that how we can utilize those technique for healthcare monitoring system, especially for chronic disease. I will show you how this technology can be utilized to self-manage diabetic patient. And finally, there will be conclusion and for future work. We are now in the fourth industrial revolution, right? So, or we can call it industry 4.0. Basically, this is a concept. I believe everyone already heard about this term. Maybe some of you already know about this concept. It is related with the change of technology industry due to increasing interconnectivity and smart automation. So we can split into a 4 stages. The first one is industry 1.0 or first industrial revolution. It is started at 1760 something. At that time, people use hand to produce the product, right? So during the production at that time, people didn't use any machine. And during the first industrial revolution, there is introduction of machine, which is powered by the steam, okay, or water power. So during that time, we can see that there is a transition from hand production to the machine. So at that time, the manufacturing, especially for textile, okay, or iron industry, agriculture, and mining, they got big help from this technology. And we shift to the industry 2.0, second industrial revolution, where we can call it the technological revolution at that time, during 1870 something, right, until 1900 something. So at that time, there is development of railroad, railroad and telegraph network. So because we have the railroad, we have train. So the trans, what you can say, the idea, transferring idea between one person to another person from different places becoming faster. And also in the second industrial revolution, there is introduction of electricity. At that time, electricity was developed. And because of this electricity, it helped the factory to utilize the production line. For example, at that time, the mass production assembly line was introduced. So yeah, at that time it was industry 2.0. We go to industry 3.0. This we call it third industrial revolution, or we can call it also digital revolution. It late 20th century, after the end of 2 world wars, right? So during that time, people utilize the computer. So the computer already utilized for communication as well as in the production process. So automation, computer electronic at that time was used to improve the productivity. And we are now in the fourth industrial revolution, or industry 4.0. In this case, we introduce at that time, in this period, cyber physical system, Internet of Things, artificial intelligence were introduced. So in order to improve the productivity, people utilize this technology, the automation, as well as computer, as well as technique from artificial intelligence. So this is just only briefly explanation about the industry 4.0 or fourth industrial revolution. Now I will give you just brief introduction also about artificial intelligence. It is also important during this fourth industrial revolution. Concerned with development of computer that able to engage human-like thought process such as learning, reasoning, and self-correction. So basically, artificial intelligence is how we can develop the computer that can think or that can act like a human. We have at least four point here. The first one is reasoning, vision, learning, and speech. So as you can see, those technology which is developed by artificial intelligence, they can act and think like a human. The reasoning here is that the computer, they can think like a human. So reasoning can be defined as a logical process of drawing conclusion. The computer try to understand from the previous pattern or previous data, and they can get the conclusion or making some production. So prediction. The computer, they can learn from pattern, or they can get the information from the expert knowledge. So that is the reasoning. And for the vision, this is also a field of artificial intelligence. We train the computer to interpret or to understand the visual, or to understand the picture, video, something like that, right? So you can see there are many cases this day. The computer, they have capability to understand the picture. They have capability to classify the image, something like that. That is the vision thing. And the third one is learning. Learning here is ability to automatically learn and improve from the experience without being explicitly programmed. So the key here is that we let the computer to learn from the previous data, and we let the computer to improve their capability without being explicitly programmed. So the scientist or the programmer here is there is nothing to, they didn't give any information to the computer. We just developed the specific algorithm so that those algorithms they can learn and improve from the previous experience. And the last one is speech. So in this speech is that we make sure that the computer they have capability to prepare the communication for human in any form. You see there are many cases for the speech recognition. For example, I believe everyone here, you have smartphone. For example, in Android operating system, you have Google Assistant. You can ask several questions to the Google Assistant, and the Google Assistant give you the answer based on your question. So this one is the example of the application for speech recognition. Now we go to IoT, or Internet of Things. I guess some of you already heard about this term. IoT stands from Internet of Things. It's comprised things that have unique identities and are connected to internet. So basically, you can think like this. Maybe you see there are many small computer or small device or sensor that they can communicate each other. The communication between them through internet. So as long as you see those example, then this example is can be classified as Internet of Things. For example, in here is that if we consider the case for logistic or supply chain, we can utilize technology, what it's called RFID, radio frequency identification. Second one, we can use small sensor or small board computer. For example, Raspberry Pi. In Raspberry Pi, we can program. We can embed several sensor that have different capabilities. The Raspberry Pi, they can gather those environmental condition and they can send it to the server side, for example. And RFID also have similar functionality. They can gather the unique identity of product and they can send this information to the server side. When those device sending the data, they can utilize what is called the internet connection, right? So in the end of the day, we can develop some software or some monitoring system which can be utilized by user, so that the user they can see the information of for example, temperature, humidity of the product, and the location, where is the product location, and so on. So when you see in this image, this one is example of RFID application in logistic or supply chains. You see the white one here is the antenna, and behind this antenna, actually there is a reader. We call it ultra high frequency reader. So this one is the product. The green one is the product, and for each product we attach a small piece. We call it the tag. The tag, there is a two type of tag, active tag and passive tag. So we use, for example, here is passive tag. We make sure that when the tag is crossing the antenna, this information will be gathered automatically by this reader, and it can be stored to the system. And the second picture is example of Raspberry Pi, small board computer, we can call it. We can embed many sensor. One of them, for example, temperature and humidity sensor. Maybe some of you are already familiar with this sensor, THD22. So this one is one of the some of the example of Internet of Things. Now also continue about Internet of Things. The thing is that the device, we make sure that for device which is connected to internet, they can communicate and exchange the data. As I mentioned before, you can imagine we nowadays the technology is getting higher and higher. The device is getting cheaper and cheaper. The speed of, for example, the device is also improved a lot. And you can imagine if this device can communicate each other through internet, then we can call it, this concept is Internet of Things. And as I mentioned before, we can utilize for various applications. For example, here, the second picture is that how we can utilize this IoT sensor device for healthcare. You see here, the patient, for example, they can utilize the commercial version of IoT device. For example, smartwatch here. Second one is glucometer. The smartwatch, we can use smartwatch to obtain the heart rate, heart rate of user. And a glucometer, we can utilize those device to gather the glucose in our blood. And the third one is that blood pressure device. So by utilizing this device, we can gather our blood pressure. And the fourth one is we can use the weight scale. And nowadays there are a lot of weight scale that utilize PLE, Bluetooth Low Energy. So we can gather our weight, and we can obtain those information and can be stored in our smartphone app with the help of PLE, Bluetooth Low Energy. And after this data is gathered in our what you call here is smartphone, for example, right? So we can send it this information to the server side, for example, and we can develop the monitoring system that can be used by the medical doctor, or that can be used by the patient itself. Now I will go briefly about machine learning, introduction of machine learning. This one is also branch of artificial intelligence. The key here is that the algorithm or the computer, we develop the algorithm that allow computer to evolve behavior based on empirical data. So the key in here is that if we use the machine learning technique, we need to make sure that we have good quality data. So our machine learning model, they can learn from the past data so that they can give some prediction. For example, for the case of supervised learning, I will give you the picture here, left one and the right one. In the left one, let's say if you're familiar with machine learning, especially for supervised learning, we split the data into two parts. First one is training data, and second one is for testing data. So for training data, we let the classifier, we let the algorithm to learn. So for example, here we have a training data. We develop the model, for example, classification model, and we make sure this model is learned from this training data. In the end of the day, after iteration process, our model is getting smarter and smarter. So after our model is getting smarter, we can apply to our model for new data or testing data. Or for example, if we have unlabeled data, then we can what we can say, give our unlabeled data, unlabeled data to train model. So in this case, after our model is becoming smart, our model will give the prediction for the testing data. So that is the basic flow of how the machine learning algorithm work, especially for supervised learning. Now, if we consider the type of type of learning, we can classify it into 4 types. The first one is supervised learning. Second is unsupervised. Third is semi-supervised learning. Fourth is reinforcement learning. So supervised learning basically is that the algorithm learn from the training data, but we have to make sure that the training data, there is a desired output, there is a target label. So for example, in the right side here, you can see the example of dataset, tabular dataset. Let's say we have input feature or attribute. Let's say we have 3 attribute and we have 1 class. So the right column here, we call it target variable or target class, or we call it just output. If we have this type of data, then we can utilize the algorithm in supervised learning. Second type is that unsupervised learning. In unsupervised learning, we utilize different algorithm. For example, clustering. For unsupervised learning, if our data set doesn't include desired output or doesn't include the target here, then we can utilize the tactic inside of unsupervised learning. So you see in this second picture here, the data set is just consists of attribute or input variable, or just column like that, right? And the third one is a semi-supervised learning. In semi-supervised learning, our data set is a combination between supervised and unsupervised learning. We have a target column, okay, but some of our data is unlabeled. So you see here in the third example, if some of the row, they have a target class, and another row, for example, here second row, they don't have target class, they don't have label. So if we have this type of data set, then we can solve by utilizing the algorithm under the semi-supervised learning. And the fourth one is reinforcement learning. In reinforcement learning, basically is the technique that enable an agent. So you can imagine it's like an agent to learn from environment by trial and error. So the key in here is that we let the agent, we let the model to learn by itself by trial and error. So the reinforcement learning, they use the concept what it's called reward or punishment, reward and punishment. When the agent or when the model they did the good decision, we, for example, a scientist or academician or researcher, we give the reward. Otherwise, if they did a wrong action, then we give the punishment. So you can imagine after so many iteration, our agent or our model is getting smarter and smarter, learning from those conditions, learning from those environment. It is important to understand the stage in machine learning. The first one is if we can split into 4 stages. Yeah, the first one is dataset preparation or pre-processing. The second one is train the model. The third one is the evaluate the model, and the last one, which is very important in my opinion, is model deployment. So in data pre-processing, actually we have so many actions that we can do. For example, you can imagine our data. If we collect the data, the data set is the collection from different source. So we as a scientist, how we can collect the data from different source, how we can combine into one single data set that can be read by our algorithm. So that is the first task. And second one is that maybe our data set, there is some outlier, there is some noise. So outlier or noise is that the data which is occur far away from their normal distribution. So how we treat those outlier? Do we need to remove them, right? Or do we need to replace them with the correct value? So that is the question how we handle the outlier. Also in this stage, maybe we can find the what you call the missing value. How we handle the missing value? So some of them, they can put the median value if it is numerical. If it is categorical, we can use the most frequent, for example. So that one is just a simple basic solution. But of course, there are many solutions to handle this problem for missing value as well as for outlier detection. And after we make sure our data set is good enough, then we train our model. We use a technique. For example, if it is supervised learning, then we use the algorithm under supervised learning. And then maybe we need to do the feature selection or extraction. Maybe the attribute, it's not all of the attributes are important. Maybe we need to choose some of the attributes which can give the high prediction to our classifier. That's what we call the feature selection. And after that, we evaluate the model. There are many metrics to evaluate the model. For example, accuracy, precision, recall, F1 score. That one is for the classification, right? And after we believe that this model is good enough, then we can implement our model for the production. So first, before we put our model for production, we need to make sure that for development stage, our model is strong. Our model is strong enough. It can give the good prediction accuracy, and after that, we can deploy for the real case condition. So that is a briefly stage in machine learning. Now, in this slide, I will start for my first case study. This one is based on our project in Dongguk University. So it is related with food, right? Food. The problem in food safety is that the customer, they want to get high quality food. They want to get high quality food, and they want to make sure that what you can say, the food that they consume will not affect to their health. And the second point is that the food industry itself, they try to improve the quality assurance and safety regarding their food, right? And the third one is that if we talk about perishable food, okay, the temperature as well as the humidity actually, but the temperature is most important factor that can affect for perishable food. So we have several problems. Then we can have a solution. For example, we can develop the tracking and tracing system. We call it traceability system. So by utilizing this traceability system, we can make sure that the movement of food can be monitored in real time. So by monitoring the movement of food, then if there is some problem, then recalls can be done effectively. One of the technology that we can utilize for traceability system is RFID, stand from radio frequency identification technology. So this technology can be used to track and trace or to monitor the object. You can see from the right picture here, let's say we have a computer. The computer is connected to this box. We call it the small box, we call it the reader, RFID reader. And the reader is connected to the antenna. So the antenna is sending the signal to the small piece object, we call it tag or RFID tag. There is a two type of tag, as I mentioned before, passive tag and active tag. So passive tag, they didn't send the signal, but active tag, they have capability to sending the signal. And the antenna, they sending the signal, and passive tag receive it and sending back, for example, and the information of tag, okay, will be stored to computer. Right. So that is the idea of RFID. So we can attach this small item, we call it a tag, to the product. For example, if we have a case study, for example, food supply chain, then we can attach this small object, we call it tag, to the product. So the tag basically is the improvement of barcode or QR code. I believe some of you, you guys already know about what is the QR code and barcode, right? So in QR code and barcode, we need to use a special device, and those device need to read those barcode, for example, in very short distance. In RFID, it is different. We can use a long distance. It can, for example, like 10 meters, 12 meter until 20 meters. So it is very strong device that can read the product from longer distance. And the application of RFID, for example, in dairy product, in cheese, in Europe, there are many cases they attach in cheese, not small cheese, but the big one. Animal or beef, they attach the small tag to the animal. Fresh vegetable also can be applied. This one, the second picture, you see the person here using the small device is called handheld reader. This one is a special RFID reader for a little bit shorter distance. Okay, and the second picture here is a RFID reader. The yellow one here is the antenna. So the forklift is bringing the product, right? So whenever the product is passing through the yellow object here, or we call it the antenna, the product information will be automatically gathered and automatically stored in the system. So that is the idea of object tracking. Yeah, so we apply those technology for kimchi industry. I think some of you already know about kimchi. In Korea, it is very famous food, fermented food. Every day, Korean people eating kimchi. This is traditional Korean food prepared by fermenting vegetables. Actually, the vegetable, it can be cabbage. Okay, they put some spices, chili. They put the onion, and they put in some special place, and they keep it in very long time and becoming fermented. And Korean kimchi industry, the consumer itself is the concern about the quality and safety of the kimchi. And from point of view the manufacturing, from point of view the company, they also realize that standardized is needed to make sure that quality is consistent. So there is 2 points here. The first one is the consumer itself, if they want to get high quality food, especially for kimchi. And second one is the manufacturing industry. They realize that their product need to be standardized. Okay, and to solve this problem, we can develop what it's called monitoring system with the help of RFID. So as maybe some of you didn't know, but kimchi supply chains, it's very short. First, the kimchi is produced in producer. Okay, and after that they move the product or the food to the distributor with the help of transporter, a small truck. And after that, with help also from the transporter, the product is moved to the customer, the last supply chain partner. So the product flow is from the product moving from the producer, distributor, and finally a customer. Yeah, system integration. So to solve this problem, we develop a system with the help of RFID technology, and also with the help of machine learning. As you know that RFID is a part of Internet of Things, because RFID is sensor device. They can read the product information in very long distance, and they can store this information to the database, for example. Our result is already published in journal in 2020, Food Control. You can see here for the low level, the product is produced by producer. After that, the product is moving to the cold storage. With the help of transporter, it's moved to the distributor, and finally go to the customer. So our idea is that for each supply chain partner here, we install the device. It's called RFID Reader, as well as the IoT device, for example, Raspberry Pi, to gather the temperature and humidity information. So in this part, we call it tag direction module. I will explain to you later. So in tag direction module, basically we will use the machine learning algorithm to detect the movement of a product, whether the product is going outside or going inside. I will explain to you later. And all of those information will be stored in a database. And finally, we can make a web-based monitoring system to show our product information, the location, where is our product in real time, for example, and what is the temperature and humidity of the product. Okay, so the first one is that it is important to utilize what it's called RFID tag. I mentioned before, for RFID technology, we have a reader and tag. So tag must be attached to the product, right? And the reader will read the tag for longer distance. So we attach our tag, passive tag, in the box. On the box, yeah, like this, the white one. And for every box, whenever the driver, for example, here forklift driver, they move the product. Here is, for example, the case from, I think this one is distributor cold storage, yeah, to the truck. So it must be go through the reader. Okay, so here we install the RFID reader, we put the antenna here, so we make sure that every product that are attached by the RFID tag must go through the reader, and this information will be stored in the database. And this one is the third picture, is the example of staff. For example, the driver, they can utilize what it's called handheld reader, the shorter distance reader, right? So we have smartphone-based handheld reader. We can attach a spatial reader, small device to the smartphone, and the driver, they can scan the product in super easy way. And finally, the product is moved to the customer. The customer, we can give them the special device so that they can scan our product. So every information of the product will be stored to the database, our centralized database. And finally, we can make the dashboard, web-based dashboard, for example, and we can see the location of product in the real time, and the movement of product, for example, from point of view map, yeah, from one location to another location. And as I mentioned before, we also utilize the IoT sensor device, yeah. So here we use Raspberry Pi. So we use Raspberry Pi, a small board sensor. We attach the THC22 is the sensor for temperature and humidity, and we install our IoT device here for in every location in our supply chains. Okay, so if you install this device, then we can gather the environmental condition, for example, temperature and humidity for every, let's say, 1 minute or for every 5 minutes, and then we can present in our dashboard, like in this picture. Now, I mentioned before that we utilize the machine learning technology, right? Until this stage, it looked like there is no problem. We just gather the data of our product, and then we store in our server side. But actually, in real case, we have a problem with RFID kit. As I mentioned before, we installed our RFID in the near to the kit of every supply chain room. Okay, so for example, here we install RFID reader near to the kit, and here is the forklift driver. They move the product through the kit, and we hope that this product, those product will be stored. The information of the product will be stored to our database. But the problem is that the reader, they cannot distinguish the direction of the tag. Distinguish mean they cannot differentiate whether the product is going inside or going outside. So this is the natural of RFID. They just get the information of ID, which is the tag ID and the time. and there is no information whether the product is going to the left or going to the right. So we want to solve this problem with by introducing machine learning technique. And also in real case, actually, RFID reader, they can read very long distance. I mean, sometimes they can read the noise, or we call it the static tag. For example, we store the product which is far away from the reader. Sometimes the reader, they can read it. Okay, so because of metal, for example, in distribution center, for example, there are a lot of steel or metal. This metal is reflecting the signal from the reader, so the signal is becoming far and far. So it's mean they can read the product from another room, which is becoming problem, right? So we want to make sure that the product that read by the reader is only close to the reader. But actually, in real case, sometimes the reader, they can read the product which is stored in different room. So how we solve this problem? We can use the technique, what it's called receive signal strength. Actually, in RFID reader, they have information of signal strength. Okay, so we will use this information as our attribute. And second one is the timestamp. Timestamp is the time when the product is read by the reader. And extra hardware, we can use additional reader to make sure that the product is read in correct way, for example. This is the solution that we already proposed. It's already published in conference 2019, detecting movement and direction. So let's say we can see from the top. Okay, we install the reader here, and we put the two antenna here. So the circle shape here is that tag, for example, or the product. And this one, the first arrow here is the movement of the product. So you see here the product is moving inside. Or for example, if we use the forklift, okay, the product is on top of forklift, the forklift is moving inside to the room. And then if we have this type of movement, we can call it the move close. So actually the product is not moving inside, but just moving close to the reader. In real case, when we have this type of movement, this tag can be recorded by our reader. So this tag is actually the problem. So we want to filter this movement, right? The move close action here. And this one is for tag movement. We need to detect whether the product is moving, or here, the last one, sorry, the product is static, not moving. So we need to classify whether the product is moving or moving close near to the reader, or just standby, not moving or static. And for the tag direction, the concept is that the product or RFID reader need to understand the movement type. For example, here is moving inside. Okay, the product is moving inside to the warehouse. For example, in the right side here we have warehouse, and the product is moving inside. Okay, and as opposite direction is that moving outside. The product is from warehouse and moving outside, for example, for delivery. And then maybe product is go to the truck and then will be delivered by the truck to another supply chain partner. So our idea is that we need to understand the movement type, whether it is going inside or going outside. There are many applications. Okay, there are many previous study that already propose this tag movement and tag direction. But in our paper, we try to solve a more complex problem. You see here, we try to to handle the problem. For example, static, moving, move close, move in, move out. So we hope that our proposed model, which is based on the machine learning model, they can classify those different type of movement. Okay, so we utilize what is called RRS, the signal strength, the time, the time when the tag is read by the reader. We use only one reader and two antennas. Now, for methodology, we need to gather the data, right? As I explained before, if we utilize machine learning technology, we need to make sure that we have data. So this data can be learned by our model. So first is data gathering, and after we gather the data, our raw data need to be transformed to feature. So the feature can be learned by the machine learning model, right? So we use the feature extraction, and finally we select several machine learning model. And in the end, we compare the performance of our machine learning model based on several metrics, for example, accuracy, precision, recall, and F1 score. Okay, for data gathering, we develop the, for example, program here is based on the Java. We connect to the reader, and here I try to simulate different movement. I try to imagine what type of movement that might happen in the warehouse, in the real warehouse. Okay, so here I try to gather. I have tried to gather several type of movement. For example, moving inside. Okay, so I move this trolley. Okay, this trolley moving inside there to the right, and then with different type of product, for example, I move to the left or moving outside. And I also consider different type movement, for example, moving close, which is I just moving near with the antenna, not going inside or not going outside like that. And also I put some noise. Okay, I put some outlier or static tag near to the antenna. Okay, after we gather the data, and if we feel and at that time I feel the data is good enough, then I can move to the next stage. So I use the single ultra high frequency reader. This is a very high frequency reader from Alien technology. I just utilize two antennas here, first antenna, second antennas, and I use the passive tag. The white one here that attached to the box is the passive tags. Okay, now after our data is enough, we can analyze the pattern of the data. The first one, the picture A here, you see we have two antenna 1 and antenna 2. So if the product is moving in, we can see the signal strength that produced by the reader. Okay, so because the product or the tag is moving, getting close to the reader, then the signal strength is getting higher. And when the product is go a little bit far from the reader, then the signal strength is getting lower and lower, right? So this is very general concept. When we put our tag near to the reader, the signal strength is getting higher. When we move our tag a little bit far away from the reader, the signal strength is getting lower, right? So first, because we install the antenna 1 is in the left side, antenna 2 in the right side, then first is that signal strength from antenna 1 is read, and after that it's followed by signal strength from antenna 2. Okay, so the pattern is like this, little bit up and then down, and then for antenna 2 is also going up and then down again. And as opposite is B. Picture B is that moving out. So the product is moving from the inside to the outside, okay, or from the right side to the left side. So because we install antenna 2 in the right side, then antenna 2 first is reading the signal strength, reading the product first, right, the tag first. So it's going up and then down, and after that it's followed by antenna 1. And the third one is the move close. As I mentioned before, I try to make a noise here because I imagine in real case in warehouse, the situation might be very complex. So it is better for me to create very complex data set. Okay, so here is moving close. Actually, the product is not going inside or going outside through the gate, but it's just moving close to the RFID reader. So you see the pattern is also similar with the first and second one. It's going up and then going down, but the the maximum value of RSSI receive signal strength is not as much as compared to the first one and the second one. Okay, so the first one it can achieve almost 5,000, but for the third one, which is move close, it's just half, like 2,500 something, right? And for the last one, static, I mentioned before that we put some noise, right? So we put some noise. If in the static, not moving product or tag, or tag which is just not moving, we see here the pattern is just plain. Okay, there is no going up or down. It just keeps stable. Okay, stable like that. So because we have four, okay, because we have four conditions, then we put the label for every condition. So class label 0 is moving in, class label 1 is moving out, class label 2 is move close, and class label 3 is static tag. So we gather a bunch of data. We got like 496 data, right? So this is the distribution you can see in this table. Now, after we gather the data and we give the label for each data, then we are ready to use what it's called feature extraction. Okay, so in this one, feature extraction, we extract information from signal strength. Okay, for every signal strength which is gathered by our tag. Okay, we obtain the minimum, maximum, mean, standard deviation. This one, yeah, standard deviation. The difference is the difference between max and min. Okay, and then count. Count is the number of reads. How many times actually the tag is read by the reader. Okay. And this one is from point of view signal strength, and the second one is that from point of view the time. Okay, from point of view the time, we extract what is called as start min. This one is seconds from beginning of tag read at the first time. So we calculate the seconds, how many seconds actually the tag is read at the first time. Okay, and so on, the max, min, standard deviation, and different. In the end, we can collect like 22 attributes. Okay, 20 attributes include RSS and scene start, which is time information that are extracted from two antenna. Okay, so the question is that why we utilize feature extraction? Because if we use the raw information from the signal strength itself, then our machine learning model will be very difficult to learn it. Okay, so we need to utilize feature extraction method so that the raw information, signal strength information, and time can be transformed into different format. Okay, can be transformed into specific feature that can be learned by our machine learning model. Okay, so finally we use a classifier. It's called random forest. I believe some of you already heard about this term. This one is ensemble method. Okay, ensemble method is the combination of the small predictor. Okay, basically the random forest work like this. We utilize many small decision tree model. Okay, 100 for example, and the decision tree is very small, and we use the packing or random space method. Okay, our packing is applied when sampling the data. Okay, so we didn't use for every tree, we didn't utilize all of the data, we just sampled. Okay, and for each tree, we also didn't utilize all of the feature, only several feature. Okay, so because we use small decision tree, and for each decision tree, they can give the prediction. Okay, so we do the majority voting. Okay, because our case is multi-class classification, then we just vote based on majority. If our problem is regression, for example, when the output is not categorical, when our output is numerical, continuous, then we use what it's called average. Okay, we average the output prediction. But because in this case we are our data set is multi-class, okay, then we use the majority voting. Now, we compare with different type of machine learning model. For example, multi-layer perceptron from neural network, logistic regression, k-nearest neighbor, decision tree, naive Bayes. The last one is our proposed model based on the what is that? Random forest. Okay, so we use four metrics: accuracy, precision, recall, and we got the very high result here as compared to another data-driven algorithm. Okay, so our accuracy is 98%. Our recall to detect the false positive is that 98% also. If you interest about this result of my result, you can refer to our previous conference paper. It was published in 2019. Okay, so that one is the first case study. I will go to the second case study. I try to make it fast, my presentation, okay? I think because the time maybe it's not enough. But okay, for the healthcare monitoring system, I use diabetes, or diabetes is one of the chronic disease, right? So what is diabetes? Maybe some of you also know, diabetes is long-term metabolic disorder which the blood glucose level varies. So actually the diabetes is that a problem of blood glucose in our body. So as you know that we have the blood glucose in our body, and the diabetic patient, their blood glucose level is vary, which means sometimes it's going up too high, sometimes it's going too low. So that one is not good. So for the normal person, okay, the glucose level must be in a normal range. Normal range means 70 until 180 milligram per deciliter. Okay, so it must be inside this range. If the range is outside the outside the threshold, upper threshold and lower threshold, then this person can be classified as a diabetic patient. So diabetes can be at least classified into three group, but actually there are many variant of diabetes, but this one is the general one. Type 1 diabetes, or T1D, type 2 diabetes, or T2D, and gestational. Type 1D is actually the problem of body. Okay, so usually the young people, they have if they have a problem with their cell, okay, in their body, they cannot produce the insulin, so they need to inject the additional insulin through the injection, special injection. Type 2 diabetes, or T2D, is actually happen when the people is getting older. For example, if our age is 40 or 50 and so on, then we need to do the medical checkup to make sure that our blood glucose level is normal. Otherwise, if our blood glucose level is too high, then maybe we can classify it as type 2 diabetes. And the last one is the gestational diabetes. It's a diabetes when this one is happen when the woman during pregnancy. Okay, when the woman pregnant, for example, 8 months or 9 months during pregnancy, usually their blood glucose level, okay, their blood glucose level is very high. So it is also very important for the pregnant woman to maintain their blood glucose level. There is two conditions that are very important for diabetic patient. The first one is hyperglycemia. Okay, the second one is hypoglycemia. For hyperglycemia is the condition where the blood glucose is exceeding more than 180 milligram per deciliter. Okay, when, for example, you go to the hospital and you do the medical checkup, and when they check your blood glucose is more than 180, then you must be what you can say, prepare. Maybe you've got the diabetes. Okay, the impact is that long-term complication. The first one is retinopathy. If our blood glucose level is too high, usually the patient, they will get additional disease, what it's called retinopathy. This is problem with the eyes. Okay, there is some problem with the eyes, and it can create the blind. Okay, the diabetes patient, they can becoming blind. And the second one is CVD, cardiovascular disease, stroke, and so on. Yeah, so it is also a dangerous situation. And hypoglycemia is the opposite condition, where the blood glucose is lower, okay, lower than 70 milligram per DL. Okay, so this situation is also not good, because it can cause the coma or even death. Okay, so if you are interested in diabetes condition, you may refer to the documentation from American Diabetes Association. Here you can see, this threshold, the lower threshold. This one is upper threshold. So the green one is the normal range. Okay, the number 3 is the healthy person. For number 1 and number 2 is, this one is maybe they got the diabetes disease. Okay, so the the yellow one is hyperglycemia, the condition where the blood glucose is very high. The red one is hypoglycemia, where the blood glucose is lower than 70. So this one is criteria for diagnosis. When you go to the hospital for medical checkup, maybe you can go for 2-hour plasma glucose test. Okay, so they give you some special glucose like drink or food like that, and then you eat it, and after 2 hours you will they will check again of your related with your blood. And if the value of blood glucose is more than 200 milligram per DL, then you classify it as a diabetes person. Random or casual, it's just random. You check randomly your blood glucose. Also, if it is greater than 200, then it is dangerous situation. Fasting plasma glucose is that, for example, maybe some of you already experienced this situation. The doctor asks you to do fasting in the night before, okay, and in the morning you will get the test related with your blood, and if the value of your blood glucose is greater than 126, then also you classify it as diabetes. This one is hemoglobin level, 3 months hemoglobin level. So in lab, they will check your hemoglobin level. If it is 6.5%, then you can also classify it as diabetes. Now, how we utilize this monitoring device, IoT device, okay? So there are many commercial versions of IoT device that we can find in the market right now. The first one, we can call it the self-monitoring blood glucose, or SMPG, or glucose level, okay? The picture is like this, a small device. For example, the brand is CareSense, AccuCheck, okay? So how we use this device is that what you can say, there is small needle, and you try to obtain the small blood from your finger, okay? And after that, you can use this device. You use the special device, and from your blood, this device, they can give you information about your glucose level, okay? So you can do it in your home as long as you have this device. And the second one is more advanced technology. We can call it glucose monitoring, or CGM, continuous glucose monitoring. So in the first device is that we have to obtain the blood every time we want to check, right? So it might, becoming a problem for several patients, because they have to obtain the blood from their finger. Maybe patient doesn't like it. So the advanced technology, they provide more convenient way, which is they don't need to take the blood every time for testing. So we can call it CGM. The way how it works is like this. There is a wire-based sensor, and they just attach this wire-based sensor on your tummy, on your stomach, like this, okay? So this sensor, they utilize what it's called PLE, Bluetooth Low Energy, and this PLE is transmitted to to this small interface, and it can be gathered in our smartphone in real time. So the good thing about this device is that they can gather the data every 5 minutes or every 1 minute, okay, between 1 until 5 minutes. So this blood glucose can be obtained continuous, every 1 minute or every 5 minutes. But the thing is that in order to use this second device, we also need to use the first device for calibration. Okay, for the first time use, okay, I'm sorry for technical problem. We back again. So the thing with the second device is that we need to use the first device for calibration. Okay, so of course this device cannot be used alone. We need to use the first device for calibration only, for first time use only. Okay, another device that can be utilized for healthcare is that weight scale. Okay, weight scale, we can obtain our weight. Smartwatch, we can obtain the heart heart rate. Okay, blood pressure, we can obtain our blood pressure. This can be raised like this. Okay, and all of those devices, they provide BLE, Bluetooth Low Energy. So the sensor can be obtained from this device, and finally we can store this information in our smartphone. Okay. Now, our proposed model is healthcare monitoring system. It's also already published in 2018 in one journal called Sensor. You can refer to this journal if you have interest in this matter. So this is how we work. We let the patient utilize the commercial version of IoT device. For example, glucometer, blood pressure, smartwatch. This one is what is that? Weight scale, yeah. So we let the patient utilize this device, and this device we make sure they have capability to deliver the data through the BLE, Bluetooth Low Energy, and this data can be obtained in their own smartphone. And after that, we develop special app here, and the data can be sent, okay, to server side. So information, for example, heart rate, blood pressure, blood glucose, weight, height, age, gender, and another user information can be filled by the user itself or can be gathered automatically from the device and can be stored to the server side. The data finally be stored to the database. And here we utilize what it's called forecasting blood glucose. So this one is how we implement machine learning model to predict the future blood glucose. Okay, and the information can be monitored by the medical doctor. So the medical doctor, we hope that the medical doctor, they can monitor their patient, real-time condition of patient, in real time, yeah. And we hope that there will be healthcare recommendation. Okay, so based on the several condition of the patient, we can generate healthcare recommendation, or maybe the recommendation is coming from the doctor, and this information can be sent to the patient through their smartphone. Okay. Now, as I mentioned before, we can utilize the commercial version of IoT device. For example, this one is blood pressure. The brand is Omron, I think. Yeah, I forget. Yeah, Omron, the brand. This one, second one is blood glucose level. The brand is CareSense. Smartwatch, we can utilize also. The last one is the weight scale. Okay, so we developed the Android app here. This one is just prototype. Okay, this is not not for production, but just for prototype. We make sure that the information from the sensor can be gathered to our smartphone app. Okay.
Excuse me, you still have 5 minutes to go.
Okay, yeah, I will make it fast. I'm sorry, Pak Hatan. Okay, to do that, we use the BLE, Bluetooth Low Energy, okay, to transfer the information. Okay, in the end, we can develop web-based application. We can monitor those sensor data in real time through the dashboard. And we develop what it's called forecasting blood glucose. Okay, we compare with previous study, and we make sure that there is a novelty in our paper. We use artificial neural network with the last 30 minutes as an input, and we use the additional time domain feature. Okay, so we use the subject. We use the. Okay, so we use the subject 12 subject type 1 diabetes. Okay, thank you. So our result has been published in 2020. You can refer to this journal if you are interested. Okay, so the thing is that this is time series data set. Okay, this is not easy way. We cannot just use the blood glucose data set as it is, and we let our machine learning model to learn from this time series data set. We need to do what it's called data preprocessing or data preparation. We split the data into training and testing. We try to generate the input. The input is based on the last 30 minutes, okay? And the output is that, for example, if we want to predict the next 1 hour or the next 30 minutes, then we do this scenario, okay? So we use multi-step forecasting using direct method. So in this picture, in the right side, basically is how the direct method work, okay? We use the public data set. If you are interested, you can what you can say, directly go to this link. 12 children with type 1 diabetes, and the data is obtained by using CGM, continuous glucose monitoring. The brand is Guardian RT, and the data is obtained for every 5 minutes, approximately for 7 days. So we use the MLP, multi-layer perceptron, one of the algorithm in neural network. Okay, so for the input layer, we do feature extraction similar as a before. We extract the minimum, maximum, mean, standard deviation, different median, kurtosis, skewness. Okay, so we split, because this is time series data set, we split the data into training and testing, 80 for training, 20 for testing. We use optimize, I think Ritsos algorithm, I forget, but anyway, we try to optimize our hyperparameter, and we found that 2 hidden layer 100 nodes each is the optimal one. We use ReLU, rectified linear unit as activation function, and Updam optimizer for weight optimization. So this one is just how we prepare our data set. As I mentioned before, we use the last 30 minutes as an input, okay, with the combination of additional statistical feature, and we use this one Y. Y is the next prediction, okay. H here plus H is the prediction horizon, how far we want to predict. Okay, we compare our performance in terms of RMSE, root mean square error. So the thing is that if we use RMSE, we need to find the low value of RMSE, okay? So we compare our model with another machine learning method. We found that our model produced low error as compared to other model. Also here you can see for the patient ID 21, for example, for prediction 30 minutes, it's very close to the real data. So our model can predict, the output of our prediction is almost close to the real data. For 60 minutes, if we want to predict the next 60 minutes of blood glucose, then our model is, yeah, pretty close, okay? It's still good enough to predict the output. Again, this one is already published in 2020 in this biocybernetic and biomedical engineering. Okay, finally, a conclusion. So we use machine learning. What I explained to you before is that I give you briefly explanation about machine learning and IoT and how we can use this technique for improving productivity, decision making, and so on. Okay, so I give you 2 examples how we can use this model, machine learning and IoT, for food supply chain, as well as to improve the healthcare service. So that's all about my presentation. Thank you very much for your attention. If you have any question, feel free to ask. Okay, so the time I give to Pak Fatkan again. Thank you.
Thank you. Yeah, thank you very much, Dr. Ganjar Alfian, for your speech. Very interesting presentation, and yeah, we have maybe we still have around 15 minutes, yeah, maximum, to the participants to ask something, yeah, to ask something to Dr. Ganjar. If you have something to ask, please raise your hand, or you can write down your your question through the chat room. So we have a question. Oh, wow, it's around. Yeah, we have 3 questions. The first, I would like to invite Pak Richard Kodong, and then the second one, we will invite Bu Virus to ask the questions, and then we have one more question from the chat room. So right now, yeah, Pak Richard Kodong, please unmute yourself, and then you can ask your question to Dr. Ganjar.
Okay, thank you very much. Morning all. Thank you very much to Mr. Alfian. We have a research about the topic, the same topic, but he have a problem. After we discuss with the real doctor, medical doctor, they said the regulation in Indonesia that have a problem about the implementation of the technology. I want to ask about that, Mr. Alfian. Thank you very much.
Okay, please, Dr. Ganjar, you can answer the question. So it is related to the issues of maybe law issues, right? Or yeah, something like that.
From a regulation.
Yeah, from a regulation. Yeah.
Yeah.
Okay.
Right. Thank you for the question from Pak Richard. Yeah, it's interesting. It's actually happened for me, for myself, and my team also in South Korea. So it's related with regulation from government. I believe the government they have very strict regulation, because if we work in the area of healthcare or medical area, the regulation is very strict, because it is related with the life or death of our patient, of our user. So that's why I believe the government or the Ministry of Health, they have very strict regulation. And at that time, in our case, we also have similar situation. So we try to, how to do that? We try to collaborate actually in our project. This is collaboration between industry, IT company, and academician, Dongguk University, as well as the as well as the hospital, the doctor that working in the hospital. So in my opinion, it is very important to listen opinion from the medical doctor, Pak Richard. So because medical doctor, they have very deep understanding related with this regulation. So because the case might be different. In our case, finally, we make our system as this one is just like it's not for the healthcare device, because in order to make the healthcare device, the regulation is also very strict. So we change our strategy. Our solution is not for medical. It's just for I forget the name, the terminology, but the main point is that it is not for medical. It is just for additional, treatment, for example, like that. So it's work fine in our case in South Korea. So I don't know, maybe in Indonesia, you can do the same, strategy, or as I mentioned before, then it is better to listen from the opinion from medical doctor and how you can, solve it like that.
Okay, thank you, Pak Ganjar.
Okay, thank you very much.
Thank you, Pak Richard, for your question. So the next question from Virus, please, Bu Virus.
Okay, thank you, Pak Fatan. I want to ask about the food traceability system. So there are 2 antennas used in the system. Is there any research about the best distance of those 2 antennas? And the second one is, if I implement the system in my warehouse, for example, and I place the antenna with different distance, or maybe I use different brand, different quality of different antenna with different qualities, do we need to relearn the model? Thank you.
Okay, thank you, Bu Virus. Pak Ganjar, please.
Yeah, question from Bu Virus. Interesting question, because it is, in my opinion, it's very practical question. How we set up the antenna. So how far we set up the antenna each other. the distance between one antenna to another antenna. So well, actually, I didn't find literature from previous study which can explain exactly how many meters, for example, the distance needed between one antenna to another antenna. So in my case at that time, I just try to set up based on the real condition in Kimchi Industry. So we go to the warehouse at that time, and I obtain the information how big the kit, okay, and approximately I got distance, for example, or 2 meters. Sorry, this one is like 1 meters, 1 meter and a half, right? So I use this information in my experiment. That's it. And for second question is that can we use this model as it is if we have different type of brand, different type of what you can say reader, or different type of antenna? Yeah, that is we need. I think we need to do the experiment first before we make conclusion to virus, because every brand, they have the output for every brand is different. For example, in RSSI, the signal strength, they have different metrics. So actually, there is a regulation, standard regulation from international, but still some of the brands, they didn't follow the regulation. So the value, the signal strength value from one brand to another brand is different. But to solve this problem, I believe when we develop our model, we use the scaling, okay, regardless the value. If we use, for example, normalization before we let our data trained by model, for example, if we use normalization or standardization, then the range of signal strengths will be fixed, right? For example, normalization between 0 and 1. So maybe if we use this model, this trained model for another what you can say, another reader, maybe it will work perfectly. But it is my guess, okay? So for final answer is that we need to do the real experiment to make sure whether it works fine or not for different brands.
Okay, hopefully that this is answering the question from the virus, and then maybe virus can collaborate with Dr. Ganjar in the future.
Yeah,
if he wants to
why not?
implement. Okay, we still have two more questions, but yeah, okay, maybe I will read the first question first. How to implement IoT on domain problem supply chain on LPG 3 kilograms subsidy in Indonesia? Maybe it's quite practical, not practical question. How to implement it to the different domains? So do you have any thought about this?
Yeah, right. So for example, how we apply this IoT, okay, this IoT for supply chains for the case study of LPG, for example, in Indonesia. So maybe we can start. We as academician, we can propose, you know, well-developed technology that can be used for traceability system with the help of IoT. For example, if we cannot use RFID, then maybe we can use another technology, the simple technology, for example, just barcode or QR code, for example. So after that, then once we analyze, we make sure that this technology can be developed. Again, final say will be the government itself. You know, the government will have a regulation whether whether they will implement the new technology, for example, RFID or another IoT sensor to the LPG supply chain or not. So we as a researcher, in my opinion, I think it is better to what you can say, explore from the previous literature any technology. So we try to compare whether this technology can be implemented for your case, for example, LPG or not. So I hope we can do like that.
Okay, thank you. So the last question from Sukma Puspitorini. So the question is machine learning with ANN give better result than another methods?
Yeah, thank you. The question from Sukma, yeah? Yeah, from Sukma. Yeah, this is very general question, whether a specific algorithm is outperform other algorithm or not. So to answer this question is that no, it's depend on the case study, in my opinion. First, the data set is affecting the performance of our model. We need to understand whether our data set is tabular data set, or our data set is text type, or our data set is image, or for example, sound type. It will also affect the performance of a model. That is the first one. Second one is that extracting the feature. How we choose the feature for our machine learning model is affecting the performance of model itself. So if we use different type of feature extraction or feature selection, it will affect the performance of classifier. So you need to analyze from this point of view also. Also, another one is that we need optimization, hyperparameter optimization. If we sometimes we use very standard model, for example, if you are familiar with Python, scikit-learn, they already provide standard hyperparameter. If you optimize those parameter, maybe you can obtain highest accuracy as compared to another model. The data distribution also affecting the model itself. Maybe you heard the terminology of what you can say, data balancing or imbalanced data set. It means the positive case is the number of positive case is lower as compared to negative case. So if you have this type of data set, imbalanced data set, you need to do special treatment to balance your training data. So there are a lot of variables that affecting the performance of data set. For short answer for your question is that we cannot say that specific algorithm is better than others. It's depend on the case study.
Okay, so it depends on the three things that you mentioned just now, the parameter, the feature extraction, and also the data, right?
Yes.
Okay. Yeah. Thank you very much, Dr. Ganjar. I think
yes, you're welcome.
Yeah, this is the end of our first session in the second day, and hopefully the speech from Dr. Ganjar could give us benefits, so many benefits, and maybe we can collaborate in another opportunity in the future. Maybe we can have a research together. So thank you again to Dr. Ganjar for the very insightful speech, and thanks to all participants for the questions. Yeah. So I will give back this session to the Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for all.
All right, this session is really interesting, right? Thank you Mr. Patan, and thank you also to Dr. Ganjar Alfian for delivering a nice presentation. And hopefully all of us can get a lot of benefit from your speech. So let's give applause to the moderator and the speaker. But before jumping into the next session, please Mr. Patan and Dr. Ganjar Alfian keep your camera open because we would like to take a picture as a documentation. And I will guide you to take a picture. I will count from 3. Okay, get ready.
Okay.
Okay, 3, 2, 1, cheese. Okay, thank you. And I would like to invite all of you to take a picture together. And please, all the participants here to open the camera, and I will guide you to take a picture. Please open the camera for the all participants here. All right, this is we have 4 parts. So I will take a photo for 4 times. All right, get all of you get ready. Okay, I will count from 3. All right, for the first part, I will take a photo first. I will count from 3, 2, 1, cheese. Okay, again. 3, 2, 1, cheese. Okay, again. 3, 2, 1, cheese. And the last one is, okay, I will count from 3, 3, 2, 1, cheese. Okay, thank you everyone.
Okay, before we jumping into the next session, we would like to remind you to fill the link form on the chat box and please write your full name clearly because it will be used for the certificate. We also would like to inform you that the material or slides from our speakers will be shared later.
Now, the next agenda is speaker session part 4, which will be delivered by Dr. Chandra Kusuma Dewa, S.Kom M.Cs, entitled TBA. Speaker session part 4 will be moderated by Mr. Domas Hattafudoli, PhD. Mr. Domas Hattafudoli is an assistant professor at the Department of Informatics, Universitas Islam Indonesia. He earned his PhD in Computer Science and IT in 2016 from La Trobe University, Melbourne, Australia, with full postgraduate scholarship from La Trobe University. Previously, he earned his master's degree from King Mongkok Institute of Technology Luang Prabang, Thailand, and his bachelor degree from Universitas Gadjah Mada, Indonesia in 2008. His research interests are mainly related to ontology, data science, natural language processing, deep learning, and big data. He explored data science and deep learning methods to support knowledge-based development and various useful applications. Outside of academia, he loves photography and cycling. To Mr. Domas, time is yours.
So we may wait for him first. Sorry.
All right, when we wait Mr. Domas, I would like to remind you to fill the link form on the chat box, and please write your full name clearly because it will be used for the certificate. While waiting, you can take a break first. Sorry everyone, we have a problem with the moderator. Maybe we will take a break for around 5 minutes. I will tell you later if the session will be start. Thank you everyone. All right, our moderator is here. Mr. Domais, time is yours.
Okay, thank you very much. Sorry for the wait. All right, so in our last session, session 4, we will have Dr. Chandra. Are you here?
Yes.
Okay, yeah.
Thank you.
Okay, Pak Chandra is already here. Okay, Pak Chandra Kusuma Dewa. So, how are you, Pak Chandra?
Fine, thank you, Dr. Hatta. How are you?
Okay, yeah, great to see you again in this forum. So, Dr. Chandra in here, he's one of lecturer and also researchers in Informatics Department, Universitas Islam Indonesia, and he got his PhD from Japan. He just come back from Japan, and now he is going to give some talk and share to us about reinforcement learning. Is that correct?
Yeah.
Okay, great. Thank you. Okay, without any further delay, let us give the time and also the share screen to Mr. Chandra or Pak Chandra, Dr. Chandra. The time is yours.
Okay, thank you so much for your warm introduction, Dr. Hatta. Let me share my screen. Can you see my screen?
Yes, the screen is
Okay.
there. Okay, yeah, we can see your share screen. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Hello, everyone. Good morning. Thank you so much for joining this session. First of all, I'd like to thank the committee for inviting me as one of the speakers for this international webinar. And secondly, I also would like to thank all of the participants for joining this session. For today, I'm going to discuss about deep reinforcement learning for robot learning. Before we go further, I would like to introduce myself. So this is my short biography. My name is Chandra Kusuma Dewa. You can call me Chandra. And you can contact me from using this email address, chandra.kusuma@uii.ac.ag. I obtained my PhD in engineering from Toyohashi University of Technology, Japan, in September 2021. So I have just finished my PhD study, and yeah, returned back to my home country. And previously, I obtained my BS and MS in computer science from the Universitas Gadjah Mada, Indonesia. And my working experience from 2013 until now, I'm a lecturer and a researcher in the Department of Informatics, Universitas Islam Indonesia. And during my PhD degree, when I'm taking my PhD, I also applied for an internship. At that time, in 2019, I was a machine learning engineer intern at one of the biggest companies in Japan, which is Honda. So at that time, I went to Honda R&D Company Limited, located at Saitama, Japan. And my research interests include machine learning, reinforcement learning, robotics, and also multimedia. So let's get started, okay? So this is the outlines for today. I'm going to discuss about three main points in my presentation. The first point is robotics and what is the relation between robotics and data science for human life. So I will talk, briefly about industry 4.0 and also society 5.0. And subsequently, I will discuss about details of robot learning. So maybe some of you never heard about robot learning. So maybe some of you have already heard about robotics, but maybe you will wonder what kind of what is actually robot learning. So is it something new, or what kind of field is that? Is it in the field of machine learning or robotic or somewhere else? So we will discuss it later. Okay, so we will talk about the definition and also the definition and also the implementation. And after that, we will discuss about the robot learning with the deep reinforcement learning. So what is actually the relation between robotics and data science for human life? So because the theme of this webinar is the data science for human life, and here in this session we, I try to discuss about the robotics, right? So here we want to focus in one of the field in robotics, which is human robot collaboration, or HRC. So according to Kerfansi et al. 2020, so human robot collaboration is a form of direct interaction between humans and robots, principally aimed at achieving a common goal. So instead of, maybe some of people will think that in the future, human will be replaced by robot, but I don't think that is appropriate. In my opinion, in the future, robots should collaborate with human, not replacing the part of the human, right? So here some of robotic researchers try to conduct some researches about human robot collaboration, which aim to make robot can collaborate with the human and share same tasks, or collaborate each another. And the second point, we want to try to combine the abilities of human with those robots. And if we see more details about the comparison between humans and robots, so human have innate flexibility, right? So human is more flexible. So, and human also have intelligence and also has the ability to solve problems. So these are the these are something that human have, but robots don't have. And if we compare it with robots provide precision, power, and also repeatability. So if we can somehow combine the ability of humans and robots, of course we can solve more complex problem in the future. And we also want to discuss about Industry 4.0. So currently, I think we are in the state of the fourth industrial revolution. So in this kind of condition or situations, so human should be, share some of his work with other devices. So as we can see from this figure, the position of human is here, and the human should collaborate with other devices, such as as you can see from here, we can see a drone, and also we can see a robot, and other robot here, and also other communication devices. So we cannot deny that currently we need to start to think that in the future robot will not take part, replace the position of human, I think. So this is the focus of our research, or my research, that in the future we want to develop a robot which can share some tasks with humans, and we can collaborate together to solve more complex problems. And this is one of the example of the applications of robotics in one of the warehouse in China. So this is Alibaba. So they utilize the robot to move some goods from one place to another. Let's see the illustration. Okay, that was the example of the collaboration between human and robots in what they call as smart warehouse. And the technology was implemented in China. And another example is also just the same, but this one is implemented in Indonesia. So Antar Aja is one of the companies in Indonesia, logistic company, and they use robot technology to help them sorting some packages. Let's see the video. Okay, thank you. Sorry. Okay, thank you. And this is another, I don't know, maybe we can also call it as, approach or framework. I don't know, maybe what kind of terms which is appropriate. But Japan has already proposed Society 5.0. And in this kind of a society, the creator have a dream in the future that we can make solution for better human life using the collaboration of AI, big data, and also IoT. So the idea is that we will have, infrastructure that compatible with this kind of a society, and we will have a lot of devices which are connected all together, and they will share some data as well as knowledge, and we will store all of the data and also the knowledge, and we'll obtain big data here. And after we get this kind of big data, then we can utilize the knowledge of the big data and using some of AI method here. Big data collected by IoT will be converted into a new type of intelligence by AI and will reach every corner of society. Can you imagine that? So as we move into society 5.0, all people life will be more comfortable and sustainable as people are provided with only the product and services in the amounts and at the time needed. And the creator also, claimed that Japan, as the country who initialized this kind of society 5.0, they think that Japan has advantages that make society 5.0 possible. At least they mentioned that there are two facts which support the argument. The first fact is that abundant accumulation of real data based in health and medical data from a universal healthcare system and a wealth of operating data from numerous manufacturing facilities. Japan has an environment rich in real and usable raw data for use in the current market economy and industry. And the second fact is that Japan has a very unique, technology, which is called cultivated from what they call as monozukuri. So it's Japan's excellence in the manufacturing of things. So they have some sort of principle that they have to obey when they want to develop some technology or something like that. So Japan's advanced technology cultivated from monozukuri and years of basic research will work as advantageous toward creating products using information technologies like big data and AI, which can then be released into our society. So this is in accordance with Industry 4.0, which has the same concept that in the future, a human will need to collaborate with the robots to make a solution for better human life. So the question is, how can we make this possible, right? So can we implement this kind of technology in our country? So in order to answer this question, so we have two possible solutions. So we need to make the robot able to do some tasks so that we can share our tasks with robots. So some tasks will be performed by robots, some tasks will be performed by humans. In order to do that, we can use the first approach, which is directly program the robots. So in this kind of approach, we need to make the analysis, detailed analysis of the problem or the task that we want the robot to perform. And then we need to manually, program the robot so that the robot is able to do the task appropriately. However, if we choose this kind of approach, then we need to, carefully and really, give the instruction to the robot to perform some tasks. And in some cases, that kind of approach will not work because, we live in a very dynamic environment, right? So sometimes the condition is not persistent. So if we, did not program the robot for a new situation or new environment, so the robot may fail to do the task. So this is the problem with the first approach, which is directly program the robot to solve or to perform the task, given task from the human. And other than that, we can use another approach, which I think, in my opinion, it is more interesting than the previous approach or the first approach, because here we want to let the robot to learn to perform the task by itself. So instead of manually or directly give the instruction or detailed instruction for the robot to do or perform a task, Here we let the robot to learn and try to solve the problem by itself. The questions are, can we make the robot able to learn by itself? So is it possible? If it is possible, then how can we do that? So what kind of approach that we can do, or is there any previous research that have have focused on this kind of field? So fortunately, there is a wider field in robotics which has a focus on that kind of things, and we call that approach as the robot learning. So based on Seagout and Peters 2012, so the definition of robot learning is as follows. Robot learning is a research field. It's kind of a specific research field in the robotics that brings together all attempts to endow robots with learning capabilities. So we want to make the robot able to learn. A robot is a mechanical system that perceives its environment with sensors. So as we can see, as we all know that in a robot like this, we place several sensors in several positions of the robot in order to obtain or get the information from the environment, and that acts in this environment with actuators. So after the robot obtain the data from the environment, we assume that the robot can make a decision or make an action or perform some action with actuators, so that the action is adapted to the perceived situation. As a result, robot learning algorithms have to deal with a limited lifespan, expensive failures, high dimensionality, and real-time requirements. Furthermore, the robot is required to choose what actions to take. So here we do not, in details give comments to the robot, such as giving some rules that the robot need to obey. For example, if given this kind of condition or data, then the robot should do something like this. So we give the if then table to the robot. So in this kind of approach, we do not do that. So we let the robot to think and perform the actions by itself. As a result, robot learning algorithms have to deal with the limited lifespan, expensive failures, high dimensionality, and real-time requirements. Furthermore, the robot is required to choose what actions to take. These requirements pose both hard constraints and opportunities on the learning process and method that can be used. So as the illustration, as we can see from this figure on the right, this is one of example of the implementation of robot learning. So in this figure, we want to teach this robot, arm robot. So this is arm robot, Baxter robot, if I'm not mistaken. And we want to teach the robot so that it is able to pour using this mug or this cup, right? So to do that, we let the human to teach the appropriate way to do that. And after the learning process, the robot will learn how to imitate the way human do to pour the cup. And we take the example from Muller et al. 2018. And let's look into more closer about the robot learning. So according to Ebarts et al. 2021, we can define robot learning as the intersection field between machine learning and robotics. So we can make a visualization like this. So the red circle represents the machine learning, and the blue circle represents the robotics. And the robot learning is lies here. So it is the intersection between the machine learning and robotics. And here we can also compare the robot learning from machine learning researcher perspective, and also from the robotics researcher perspective. So from machine learning researcher's perspective, robotics is an appealing medium to study, as it provides a lens into the constraints that human and animals encounter when learning. And on the other hand, using learning-based techniques is appealing because it can enable robots to move towards less structured environment, to handle unknown objects, and to learn a state representation suitable for multiple tasks. And the second point is from the robot researcher point of view. So we can also say that in the field of robot learning, we want to implement machine learning techniques or machine learning algorithm in the field of robotics to make the robot able to, perform some tasks that can help humans. So that's the summary. And second question is, or the next question is, how to implement robot learning? So for example, we have a robot like this, PR2 robot, and we want the robot able to put this kind of block inside a cube, and we don't want to manually, give direct instruction or detailed instruction to the robot. And here we want to use the robot learning approach to make this robot able to do that. What can we do to make that kind of condition happen? So here in robot learning, we can use some machine learning method to make it possible. And here our focus is in this field. So we want to use the reinforcement learning to make the robot able to learn and solve this problem, which is making the block goes inside this tube. So some of you may have already familiar with supervised learning in machine learning, and also others also have familiarized with unsupervised learning. But I don't know, maybe some of you never do some research about reinforcement learning. So in this session, we will discuss in more details what reinforcement learning is and how can we implement the reinforcement learning for robot in order to perform the robot learning. So what is reinforcement learning actually? According to Sutton and Bartow, 2017, reinforcement learning, or RL, is goal-directed learning. So here we define that this kind of learning or reinforcement learning is a goal-directed learning. So goal, it becomes the main focus. So here we want the robot to be able to solve or perform some task, and able to do the task becomes the goal of the robot. And in order to do that, we want the robot to interact with the environment. So the learning process is performed by the interaction between the robot and the environment. In that kind of learning, so we want to make the robot able to learn what to do and able to learn how to map situations into actions. As we all know that we can place a lot of sensors in the robot, and using that kind of sensors, we can make the robot able to, get the information or data from the environment. And after obtaining that kind of information, we want the robot able to somehow map the data into the actions. Of course, we want the robot to, do the appropriate actions. And the last point, we also want the robot to learn to maximize the numerical reward signal. So in the interaction of reinforcement learning between the robot or the agent and its environment, here we need to provide the appropriate reward functions so that the robot will know what kind of task that it needs to do. And we also need some learning algorithm that can make the robot able to maximize the reward. So here I give you one of illustrations. So a robot sitting and thinking, and it thinks when I perform an action, I will get a reward. So this is kind of interactions that we have in the reinforcement learning. So whenever the robot performs an action in the environment, then we need to give the feedback to the robot. So if the action is appropriate, then we will give reward to the robot or the agent. However, if the robot doesn't do the task properly, then we need to give punishment to the robot. So that is the basic mechanism of the reinforcement learning. And the robot thinks like this in this figure. I will learn with trial and error. So if an agent is given that kind of situation, then one of the possible condition for the agent is it will do the trial and error strategy to maximize the reward if we have the appropriate learning algorithm. So this is the details of the reinforcement learning algorithm, the reinforcement learning mechanism. Sorry. Here we will have an agent which can be represented as a robot, and also we need the second, we can say it as ingredients. Second ingredient of the reinforcement learning is the environment. So we need the agent to be able to interact with the environment. From the sensor placed in the agent or the robot, the agent or the robot need to get the observation or the information from the environment here, as we draw it with this arrow. And after that, by using some learning algorithm, the robot will maximize the expected sum of reward. And we'll take the actions with any actions with which will maximize the reward. Here, as represented as this arrow, the agent or the robot will execute or perform the action in the environment. So this is kind of a closed loop interaction between the agent and the environment. And after the learning process ended, at the end of the training, we will have what we call as a policy. So policy is, something that the product or the output of the reinforcement learning, which able to map the given state into appropriate actions. And in the implementation, we can, implement this kind of agents using, for example, neural networks. So here we can train the neural networks, which can map this, which can map the state into actions, and which will maximize the reward. So basically, here we just want to train neural networks. For example, if we implement the reinforcement learning agent as neural networks, the goal is we want to train that neural networks so that it can map given state into appropriate actions. Sorry. Okay, these are the reinforcement learning ingredients. So in order to implement the reinforcement learning mechanism, we need 3 ingredients. The first ingredient is the agent. Here we can implement the agent as a neural network models, which is designed to map states into actions. And here we want the robot to you know to maximize the given reward. And the second environment is the second ingredient is the environment, which is the place for the agent interact in the learning process. And to implement this kind of environment, we must follow the what we call as Markov decision process, or MDP, that can be represented with set of states. So the environment should be able to be represented as a set of states, and it should be able to accept actions A, and it should have it has a state transition probability function P. So given some actions to the environment should be able to move from one state into another. So that's the illustration of the definition of a Markov decision process. And the last one, we also need to define a reward function R, which can somehow guide the agent to able to learn the appropriate policy according to the task or the problem which is given. And the third ingredient is the learning algorithm, which can force the agent to maximize the future reward. So these are the ingredients if you want to implement the reinforcement learning mechanism. Next, we will discuss about deep reinforcement learning. So what is the difference between reinforcement learning and deep reinforcement learning? Previously, we have discussed about reinforcement learning, but in this slide, we will discuss about deep reinforcement learning. So this is the illustration of the deep reinforcement learning model. As we can see here, the agent is represented as deep neural networks. And here we let the agent to interact with the environment. The agent can get the observation from the environment, and also it will get the feedback or reward after the actions which is generated from this agent is performed or executed in the environment. Here we also can see that we want to have an agent which can map the given observation, this one, into actions. Deep reinforcement learning, or DRL, is the combination of deep learning and reinforcement learning. In DRL, the agent is implemented as a deep learning model so that it can map states into actions better. So the deeper the neural networks, the better the agent can map the given observation or the state into appropriate actions, which can maximize the reward from the environment. For the illustration, I will give you one example of the implementation of DRL. But this time, this time the implementation is in computer game. So in their paper, in Nature, Ni et al. 2015 implemented the DRL agent based on convolutional neural networks, or CNN. This is the proposed model. So given the screen of the game, this is the game screen. We use the game screen as the input of the agent or the neural networks, and using the CNN, here we can see that there is a convolution layer here, and also the ReLU activation function, and we also have another convolution layer here, and we also have the fully connected layer here, and we want to map the given image into some actions. So here the agent will be able, after the training, it will be able to choose which action to be taken given the image that can maximize the future rewards. And this is one of the example. Here we use the environment of Atari Breakout. This is one of the classic game. And here we use the deep Q learning algorithm. And for the reward function, we implemented the researcher implemented the reward function based on the game score. So let me play the video. This is the beginning of the training. As you can see that the agent is not able to play the game because we previously actually did not give any information about the game to the agent. So the agent will just try, will use the strategy of trial and errors to try to play the game to maximize the reward. And in this problem, the agent will try to obtain a higher score. And after some training, as we can see from this video, the agent is able to play the game. So in this game, the input or the state of the environment will be the screen of the game. Sorry. Will be the screen of the game, and the action or the output of the agent will be the actions taken by the agents, which are moved to the left or moved to the right. Okay. Another question: is deep reinforcement is suitable to train robots? As we can see from this illustration, the answer is yes. So this is an illustration of fetch robot. This is in this kind of robot, we can have a lot of data from a lot of sensors attached to this robot, such as the camera, the lidar, the IMU, and etc. And we can use the information obtained from those sensors as the state or the input for the agent, or in this way we can implement the agent as the neural networks. So we can use the data obtained from the sensor as the input for the neural networks, and then we can train the neural networks so that it can map the given state into appropriate actions. So this is why deep reinforcement learning is suitable to train robot, because we can have a stream of data if we place a sensor into this kind of a robot. It means that this becomes one of the advantages of deep reinforcement learning compared to other approach in machine learning, such as the supervised learning. So maybe some of you will think that, is it possible if we just train the neural networks using the supervised learning? So the answer is, yes, it is possible. So if we, but we need to, because we implement the agent as a deep neural networks, it means that we need to prepare enormous or very large data set in order to train the robot or the agent so that it can map the state into actions. But by using the deep reinforcement learning approach, we don't need to prepare the data set with the labels. So in this kind of approach, we just need the environment, and we will let the agent or the robot interact with the environment, which will indirectly collect the data sets for updating the neural networks. So that's one of the advantages of the deep neural networks, or sorry, deep reinforcement learning compared to other approach in machine learning. How to implement the deep reinforcement learning for robot learning? So to implement the TRL mechanism for robot learning, we need to implement the environment first. And after that, we also need to implement the appropriate reward function to make or which can guide the robot to perform a specific task correctly. So for some illustration, I will give you this image. And for the environment, we have two options actually. We can use the realistic robot simulation to perform the training. And the second option, we can just use the real world environment and let the robot do the learning in the real world. And this is the comparison of the simulation environment. So in the left hand side of this slide, we can see the simulation environment, which is implemented in the gazebo simulator. So this is one of the very famous realistic simulator in the field of robotics. And at the right hand side of the image of the slide, we can see this image, which is the real world environment. So in this kind of approach, we just let the robot to perform the training in real world. And I will give you one of example of how we can implement the reward function. So this is one of research from Pang et al. 2020, which aim to develop a robot which able to follow a specific person. Here, the target person is a person who wear yellow t-shirt here. And the robot is equipped with the RGB camera placed here. And we can control, or the robot can move forward, turn left, and also turn right. To develop this kind of robot, or to train this kind of robot, the researcher used the deep reinforcement learning approach, and they design specific reward functions like this. So whenever the robot see target person inside the image taken from the camera, or the place here, we will give a reward +1 here. And whenever the robot doesn't see the target person, we will give a punishment here, so by giving -10 to the robot. So let's play the video for the illustration. This is the image taken from the camera, the video taken from the camera. And this is the image that the robot sees. As we can see from this video, the robot tries to place the target person at the center of the camera or the image. And this is the another illustration when we place another person near to the target person who wear another color of t-shirt. and let me see whether the robot can still follow the target person or not. Yeah, so the robot is still able to follow the correct target person. This is another example. Even though the robot sees another person, but it still can follow the correct target person. To implement this kind of robotic system, the input for the neural networks will be the image, only this kind of image taken from the camera, and the agent or the neural networks will map the given image, which become the state of the environment, into appropriate actions, which are turn left or turn right or move forward. And this is another example of the training example with real world environment. So in this kind of illustration, we do not use the simulation. So we just let the robot to directly interact with the real world environment and let it learn. So let's see the illustration. In this research, the researcher wants to train a leg robot to work directly in real world. And after 108 minutes with soft actor critical learning algorithm, this is part of the specific learning algorithm in deep enforcement learning, the robot can work appropriately. After obtaining the optimal, what we call as the optimal policy, the robot even can work properly under some disturbance. Let's see the illustration. After 36 minutes, as you can see that the robot is slowly can walk appropriately. This is after 1 hour. After 90 minutes. This is the final of the training. As you can see, the robot is able to walk. And this is the testing. We give some, disturbance or obstacle from in front of the robot, and the robot is still able to move or walk correctly. Even the researcher also tested the learned policy in different terrain. And this terrain is not seen in the training. However, the robot or the agent is still can walk properly. And this one is the DRL training sample with simulated environment. Instead of using the real world environment for the training, here the researcher used the simulated environment, which is implemented in Mujoko simulator. And after the learning process is done, the learned policy will be transferred to the real robot using the what they call as the domain randomization technique, so that the optimal policy can be transferred from simulator to real world smoothly, and they call it as the sim to real transfer. this is the testing in the real world robots. So first, the researcher trained a simulated agent in the Mujoko simulator in order to obtain the optimal policy. After that, the optimal policy is transferred into the real robot. This is the robustness test. As we can see that the robot is still able to work properly, even though we give some disturbance to the robot. The researcher also tested the robot with different terrains and also put some, load to the robot. That's all for my presentation. Thank you so much for listening.
Okay, great. Thank you very much, Pak Chandra, Dr. Chandra, for the presentation about reinforcement learning. So the talk is started from the idea that human and robot can collaborate each other. So there is so we shouldn't be worried that that robot will replace human, but there is some point that from the human factor that cannot be replaced by robots. So in reality, we still have to I mean the implementation or the application on the field side is that the human and robot is collaborate together. And also from that point of view, we move to the robot learning things, and Dr. Chandra share to all of you about how we can do the robot learning process, and also introduce to us into reinforcement learning methodology. Okay, so now it's time for the question and answer part of the session. Please, if from the participants here, if you have any question, you may raise your hand and unmute yourself and start to ask questions. Is there any questions from the participant? Okay, not at the moment. Okay, maybe I will start for myself. So hopefully other participants can also participate. And suddenly got a lot of bunch of questions that going to be asked to Dr. Chandra. All right, so maybe it's not too technical questions. I'm just curious, since you have an experience in one of the largest a company in Japan, which is Honda. And from the statement that you gave before, that human and robot collaborate together, and robot cannot, cannot replace humans. Is it possible for you to tell us the story? What kind of collaboration happened in that company, in the
Okay,
Honda
thank you.
company? Yeah. If it is not classified, of course. Okay, maybe that's one point first before we move to the next question, maybe from the participant. Thank you.
Okay, thank you so much for the question, Dr. Hatta. So at that time, I spent only 1 month at the Honda R&D actually, but I got a lot of experience. I think interesting experience for me at least. So at that time, I learned about how the company tried to make a robot can collaborate some tasks with humans, and they at the time they tried to build a special robot which is able to help the farmers in the agriculture. So they want to develop a special robot which can automatically harvest some vegetables or fruits, something like that. And they in their research they use deep learning and also deep reinforcement learning to make the robot able to do so. So they use a lot of they place a lot of sensors into the robots, and using the information or data obtained from the sensor, the robot is able to automatically harvest the vegetables and fruits. However, they do not claim that the robot or agriculture robot will replace the position of farmer, because some of the tasks still cannot performed by the robot, of course. And in that kind of case, they let the real farmer to assist the process of the harvesting the automatically harvesting the vegetables and also the fruit. So in order to perform the training or the learning, they need the real farmer as the expert to form the knowledge that can be transferred to the robot. So that's that's the claim that the company guarantee that the robot will not take humans job, something like that. Hopefully that answered the question.
Okay, thank you for the answer. Is there any question from the participant?
Hi, Dr. Chandra. I have a question. I'm Dr.
Okay.
Atika.
Yeah,
thank
Dr.
you.
Atika.
Yeah, very nice presentation. I really like the information I got from your presentation. But what I feel like to ask, like, why only Japan in your examples are much quoted? Is only Japan is the model country doing too much for robotics, or is there any other model countries as well? Especially if we talk about in terms of smart farming, where IoT is involved or something, which country, top 5 countries are more towards involving IoT or something like this? Thank you.
Okay, thank you so much for the questions, Dr. Atika. So I think the implementation of deep reinforcement learning is not just limited in the agriculture robotics. So maybe we can also deploy some models in IoT and in other fields, because in my opinion, I see that reinforcement learning is just one of approach to train neural network models. So given neural networks models which able to map some input into outputs, we have some options to do the training, and deep reinforcement learning is one of the options that we can take. And so this can become a global or general solutions that can be applied in any field, I think, not just limited to the farming or agriculture, but we can also maybe somehow deploy the model into other devices in IoT or something like that. I hope that it answered the question.
Thank you.
Okay, thank you. There's one question on the chat line. Do you want me to say it out loud to you, or can you see the question, Chandra?
Okay, I will read by myself. Thank you. I have
Right.
a question. Can
Yeah.
you tell us about similar robot that can be used to help human? For example, to save people from disaster like eruption or something like that, because you just mentioned that example from industry. Is that happening in Japan? Okay, thank you so much for the question, Ms. Salu Muharoma. So, can we apply robotics technology in the, to save people from disaster? I think so, because we can develop a robot with some basic skill or skills that can be performed by the robot, such as navigation, or can make the robot able to move goods from one thing to another. In the case of disaster like eruptions, we can make maybe in the future we can develop a robot which is able to navigate or help people to move or navigate fastly using the sorted path. We can train, in that case we can train we can use robot learning technology to train the agent on neural networks, which can enable the robot to do the navigations in the shortest path, so that the people can evacuate quickly using the robot with the help of the robot. That's one of the example of the implementation of robotics in the disaster or eruption. And in Japan, people also have already used some technology in robotics, using robotics. One of the examples is that some of the industry heavily depends on the robotics to do the productions, such as in the automotive industry. For example, in the place that I took the internship program in the Honda, and some of company in Japan also use robotics to help farmers to do the to do farming. Yeah, that's the answer. I hope it yeah, thank you.
Okay, and there's another question from Richard. How about the robot microprocessor or processor resources to manipulate deep learning, machine learning? I'm not sure in what aspect of the microprocessor. Maybe how big or how fast the processor needs to be, that we need to be prepared in order to do that learning. Maybe. Yeah. Yes.
I see. I think it's an interesting question from Mr. Richard. So, as we all know that in order to train the deep neural network models, we need a lot of resources. And is it possible to deploy the model in the robots, which somehow maybe it will have very limited resources, but in that kind of cases we can use the robot learning strategy using the simulated environment, I think. So using the simulated environment, the training is conducted or processed in the server using the simulation. So in the first phase, we develop a simulation of the interaction between the robot and the environment. And after that, we will obtain the optimal policy from the simulation. So to obtain the optimal policy or the optimal neural networks model, we use the server, and after that we can just transfer the learned policy or the optimal policy to the real robot. I think using that kind of strategy, we can overcome this kind of problem. And I also see another question.
Yes, there's another question from Matthew.
Okay, I have a
Yeah,
question.
Mas Matthew asks about your opinion about robot in Indonesia.
Okay. Yeah, I'm a very optimistic person. So I do believe that robotic technology will have good future in Indonesia, because yeah, there are a lot of universities in Indonesia which offers courses related to the robotics, so including Universitas Islam Indonesia, Department of Informatics. So if you're interested, you can learn robotics from that kind of universities. And hopefully in the future there will be many robotic researchers who can develop more robots which can help humans in Indonesia. And another questions.
Yeah, there's another question. What prerequisite of knowledge must be mastered before starting to learn about reinforcement learning?
Okay, thank you, Mr. Iqbal. To start learning about reinforcement learning, I think you need to learn about the basic of machine learning first. So maybe as the starting point, we can just learn about another approach, which is the supervised learning. So in that kind of approach, we will learn how to, how we can use the data, lab data, to train a model. In this case, it is neural networks. And we can slowly move to reinforcement learning. So in reinforcement learning approach, we do not manually collect the data set, but we will develop or provide a specific environment for the agent or the neural networks, so that we can automatically collect the data set and yeah, using some kind of learning algorithm. So we can start from the basic of machine learning first, and after that we can move to reinforcement learning, I think. And I think that's all the questions, Dr. Hadi.
Yeah. Okay. Or maybe I have another answer for that. If you haven't do your master degree, you can ask Mr. Chandra to teach you by himself. You can apply for master degree in UII, yeah, informatics department, and you can ask Mr. Chandra by yourself and ask him to teach you directly. Okay. Is there any question? Another question for Dr. Chandra. Oh, okay, Mohammed Pikara. Yes, please.
First of all, thank you so much for the presentation. My question being, I'm just curious in general. I've noticed in the previous years that machine learning is like defeating, or it's becoming better than humans in so many aspects, in particular fields. So my question being, is there a field, or is there a place where machine learning cannot like be better than human?
Yeah, I think so. I think the performance of machine learning depends on many things. For example, as mentioned from the previous speaker, Dr. Ganjar Alfian, he mentioned that in order to train the good models, so we need a good data set, right? So if in some case that we cannot obtain a specific amount of data set to train the model, then we cannot train the model. And in that case, human performance, of course, will be better than the machine learning. But in some cases, I found a research that, especially in the field of reinforcement learning, some researchers can build a model using the reinforcement learning approach, which can outperform the human capacity. Because as I mentioned in the slide, that there are some aspects that robot can have, but human cannot, and vice versa. It means that in some cases, machine learning can beat the human, but in some cases it will be otherwise. Thank you.
Thank you so much.
Okay, great. All right. Is there any other questions from the audience? From the participant, we still have a couple more minutes before closing. All right, so okay, no more question. Okay, if there is no more question from the participant, I still have one quick additional question for Dr. Chandra. So this is the continuation from the question asked by Richard. I'm also curious, especially with the example that you presented before regarding to at least the robot that is trained to follow a person. In that video, I think the training, the learning process is done on the device. I mean, because I didn't see any cables that is connected to the device and so on. Do you have any experience if we want to train a robot they're using the visual data, just like the example before, what is the minimum requirement, probably roughly, or what kind of, or do we still need to use a mini personal computer, for example, with an actual, I mean, big GPU to actually train the model, or we can use some, actually it can be trained by using a very simple embedded devices such as I'm not sure Jetson Nano or probably Raspberry Pi. I think this is a everyone question. Your presentation is interesting, and maybe many people in here are interesting already to actually try to do it, to have their own robot and try to follow them wherever they go. So maybe is it possible for a person without any funding given to them to actually start by themselves? Yeah, probably maybe you can give us some suggestion or where to start and how much we have to prepare for that kind of things to be done.
Okay, thank you so much for the question. Yeah, I think one of the issues in robotics is that we somehow will have limited resources when we want to deploy some robots. So in the videos which I have presented before, so yeah, it is correct that the training is presented directly in the robot. So in that case, they use robot which has the GPU to do so. So because the input of the robot are images, and we want the robot able to map the given images into appropriate actions. However, in that research, the researcher actually combine the reinforcement learning approach with the transfer learning. So in that case, they first train the model using supervised learning first. So they collected the image dataset, and trained the model using supervised learning, using the computer, the PC, very powerful PC. And after that, they also put the label because they use this supervised learning. And after they get the initial model, they transfer the model to the robot. So after that, they use the reinforcement learning to optimize the model. Using that kind of approach, I think that we can save the resources, and we can also save the training time to make the robot able to do that kind of task. And with the issue of the limited resources which the robots have, I think one of the solution is that we can take is by using some of libraries provided by some of the companies. For example, if we want to deploy a model into a device with limited resources, we can use, for example, Tensor RT or something like that. Using that kind of library, it is the library is designed for that kind of purposes. And another library which can also use is we can use some other, such as Deepstream. So, for example, NVIDIA also provide a framework called Deepstream, which can make devices with limited resources can stream video data and somehow compress the video, and after that the data can be fed to the neural networks. And in the inference, we can use another library such as Tensor RT, which can make the inference time faster. Yeah, that's all, I think.
Okay, thank you very much for the very nice answer. And I will let one more question, if any, from the participant. That will be the last question for today's session. Is there any more question? Since it's already 11:15. All right, if there is no question, so thank you very much, Dr. Chandra, for being here with us and share a very interesting topic to us, especially in reinforcement learning topic. Thank you very much, Dr. Chandra. I hope we will be seeing you again soon in other events. Thank you very much, Dr. Chandra, and also that's from me. Thank you very much for all of the audience that already give your time to actually sitting here in our Zoom room, and hopefully the knowledge given or shared by all the speakers will be giving advantage for all of you and for your career and so on. Okay, thank you very much for your attention. I apologize if there is something that doesn't fit you, and thank you very much once again, and I will give the time back to the Master of Ceremony, Mbak Salu and Mas. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Chandra.
Okay, thank you, Mr. Domas, and thank you also to Dr. Chandra Kusuma Dewa for delivering a nice presentation, and hopefully all of us can get a lot of benefit from your speech.
Before we jumping into the last session, please, Mr. Domas and Dr. Chandra, keep your camera open because we would like to take your picture as a documentation. And I will guide you to take a picture. Okay. And Mr. Okay. Okay. I will start. I will count from 3. All right. Get ready, please. Okay. 3, 2, 1. Cheers. Okay. Thank you, Mr. Chandra and Mr. Domas.
Okay, ladies and gentlemen, that's all for today. Thank you to all the speaker, moderator, and participant. And sadly, this is our last meeting, but we hope in the future we can meet again. Let's close this agenda by reciting Hamdalah. Alhamdulillah Rabbil Alamin. But before that, we would like to remind you to fill the link form on the chat box and please write your full name clearly because it will be used for the certificate.
We are, as Master of Ceremony said goodbye. I am Salu and my partner
Ashfi.
We do apologize if there was any mistakes. Thank you for your participation.
Wassalamualaikum warahmatullahi
wabarakatuh.
Waalaikumsalam. Thank you all. Thank you all. See you later. Thanks for joining us.
Thanks you all.
Thank you.
Thank you. Thank you. Thank you, Dr. Domas.
Yeah, thank you all.